Welcome to my Artificial Intelligence through Artificial Intelligence YouTube channel and the Introduction to Deep Learning and PyTorch course. In this video and the upcoming ones, we will explore the major categories of activation functions and the most popular nonlinear activation functions. Let's begin with the main types of activation functions. As you know that activation functions are very important components of neural networks, determining the output of a neuron based on its input. They can be broadly categorized into binary step, linear, and nonlinear activation functions. The binary step function outputs either 0 or 1 based on a threshold. This is its mathematical representation. As you can see here, output is 1 if x is greater than or equal to 0, otherwise output will be 0. Major characteristics of binary step function include: it outputs R binary, that is 0 or 1. It is not suitable for gradient-based optimization. The binary step function is rarely used in modern neural network. Real-world example: the binary step function was used in early perceptrons for binary classification tasks, such as determining whether an email is spam or not spam. A linear activation function outputs the input directly without any transformation. Its major characteristics are: output is proportional to the input. The derivative is a constant, which means it does not introduce nonlinearity. Assembling multiple linear layers is equivalent to a single linear layer, making it ineffective for deep networks. Real-world example: predicting house prices based on features like size and location uses a linear relationship. For non-linear activation functions, please watch my video entitled Module 6. Activation functions in deep learning at my YouTube channel Artificial Intelligence through Artificial Intelligence. So far, we have gained a solid understanding of the major categories of activation functions. Now, let's explore some key nonlinear activation functions in detail, starting with the sigmoid function. Its mathematical representation is: the sigmoid function is indicated by Greek letter sigma and is given as 1 over 1 plus exponential of minus x. It is also known as the logistic function. It is foundational in logistic regression models for binary classification. It draws an S-shaped graph, transitioning smoothly between its minimum, that is 0, and maximum, that is 1, bounds. It transforms inputs into probabilistic outputs between 0 and 1. Large negative inputs are mapped close to 0 and large positive inputs are mapped close to 1. It returns 0.5 for an input of 0, serving as a decision boundary or threshold value in binary classification. The values greater than 0.5 predict one class, while the values less than 0.5 predict the other class. Evolution and use of the sigmoid function in neural network. In the early days of neural networks, the sigmoid function was widely used as an activation function in the hidden layers of multilayer perceptrons, convolutional neural networks, and recurrent neural networks. However, its application has significantly evolved over time. Currently, it is not used in hidden layers due to issues like vanishing gradients and saturation. Instead, rectified linear unit and its variants like leaky ReLO are preferred due to their computational efficiency and ability to mitigate gradient-related problems. Despite this, the sigmoid function is still utilized in certain recurrent neural networks like LSTM and GRU to regulate gating mechanisms. Additionally, in binary classification, the sigmoid function is commonly used in the output layer to convert inputs into probability scores, which are then used to determine the final class label. See this figure, which demonstrates the application of the sigmoid function in the output node. It shows that if the probabilistic output is less than 0.5, it indicates no rain. Otherwise, it predicts rain. Now let's explain sigmoid function with a real-world example. Imagine a light switch with a dimmer. If the dimmer is turned very low, which indicates large negative values, the light is almost off. If the dimmer is in the middle, the light is at 50% brightness. If the dimmer is turned very high, which indicates large positive input, the light is almost fully on. This is exactly how the sigmoid function works. It smoothens extreme values towards 0 or 1, making it useful for binary classification problems. We typically avoid using the sigmoid function in hidden layers due to some drawbacks such as the sigmoid function suffers from vanishing gradients, also referred to as gradient saturation. It leads to slower convergence during training. The outputs of the sigmoid function are not zero-centered, making the optimization process less efficient. The function involves an exponential of z term, which makes it computationally expensive compared to other activation functions. To conclude today's module, sigmoid is replaced by ReLO in MLPs and CNNs but still relevant in RNN gating mechanisms. Sigmoid function is critical for binary classification tasks due to its probabilistic interpretation. That wraps up today's video. I hope you now have a good understanding of main categorizations of activation functions and the sigmoid, one of the non-linear activation functions in deep learning. If you found this helpful, don't forget to subscribe, like, share, and comment to stay updated with this series.